Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, episode number 12. Dart. Take it away, Jason.
Hey guys, so we had a little bit of a hiatus. I was kind of doing a whole lot of traveling, wasn't in my residency very frequently, and Patrick is a new father. So
oh no!
Congratulations.
Who decided that was acceptable?
So
people did not get a vote on that, I promise you.
He didn't get upvoted.
No.
Oh, tear. But yeah, so it babies have sort of been like a recurring thing, you know, like it's like one person has a baby, and a lot of our friends are having, like my wife and I, a lot of our mutual friends are having babies now, and so it made me think about kids. And one of the things that I think a lot about kids is I think about how they relate to the internet and to tech and things like that.
You should think about diapers.
Yeah, well,
many diapers.
I told, Lindsay that like we could just adopt a 12-year-old and get to like the cool part, where they're into tech and computers.
Have you met many 12-year-olds?
No.
Okay.
Yeah, maybe that's not such a good idea. But yeah. So, I was thinking like when we were kids, our parents, well, maybe your parents were more savvy than mine, but my parents didn't understand anything about computers or the internet. My dad, he thought the computer was like an extension of the sewing machine, using the mouse with his foot and everything. It didn't make any sense.
That is awesome.
So we sort of had complete freedom on the internet. And, you could argue that maybe it made us more responsible. Maybe it made us, more, adventurous, It was really, the internet was kind of like the wild, wild west, and we could, have access to anything. And now, the internet's become so big, and there's so much content on there, and also it's so more accessible that you have to wonder, for kids who are growing up nowadays, should you censor their internet, or should you sort of give them the same free reign we had?
Yeah, it is interesting. We actually had some friends of ours who have a 1-year-old over, and the 1-year-old was able to get on the phone and bring up YouTube and find Sesame Street videos and watch them on YouTube. And I looked at the parents and said, you realize there's other stuff on YouTube as well, right? And so, and I guess that's only a relatively dangerous place to go on the internet. But, yeah, it is an interesting question. So a lot of people do try to install these nanny software or filter software and block certain sites. And the issue I have with those is that they don't really work. And then when the kids get older, and if they haven't learned what's acceptable and what's not, they just figure out ways around it. And so it's not particularly effective. What I think is effective, is educating yourself. So we have an advantage of, we already kind of know about computers, so we understand these things. And, tell your kid that, look, I need to be able to have access to your accounts. Now, you don't ever use that, and hopefully you never have to, but you need to share with them that, look, this is important. I need to be able to know what you're doing. And it's for their safety. Just like you wouldn't allow them to go with people you didn't know to the park or whatever. And I think it's important for them to trust you, to not constantly be reading everything, but they need to know that you can if something happens, and that they need to know that that's the kind of thing that they need to be thinking about. So I think that's one way. And another way is also to have the computer in an area or have the usage pattern set up such that, especially when they're really young, that the usage is very, very limited, right? So that you only use the computer when they're there with you, that kind of stuff. Sorry, they only use the computer when you're there with them. Other way around, anyways.
Bring your daughter to work every day.
Oh, no, that'd be hard. But, so that you're watching them and helping teach them good habits, just like the state requires you to have a parent or some adult who's hopefully responsible around when you're learning to drive. Same kind of thing. As they're learning, they need to have somebody responsible around so they can learn good habits and, what's the right way to do things. And then even as they continue to grow up and gain independence, still to have it somewhere where they know somebody will, be around and pay attention to what they're doing, and that, show an interest in caring about what they post online and, sharing with them the danger about. I think it's even different than when we were growing up, because when we were growing up, it's still mostly consumer oriented. So you would go on the internet and consume things. You would read things. You would, go to stuff. And that was a concern, is you would view something that was damaging to you or that your parents didn't want you to view, versus the relatively controlled media of like a TV or CDs or DVDs or whatever that they would kind of know about. But I think the extra danger that faces children today that is newer is this ability for phones and computers and everything to take video and then post that online, or pictures as well.
Yep.
And I see that a lot. That's very dangerous, because then the problem isn't you get damaged, and then nobody kind of knows about it except you and maybe your parents or whatever, but that you could actually post something that's damaging to you and your family, for everybody to see. And then the way the internet works, that's really hard to remove references to that,
Yeah,
and
definitely.
if it's even possible. And so I think that is a far more dangerous thing, is people having YouTube accounts where they allow children to upload to YouTube, or even having a Facebook account. Reading other people's Facebook statuses can be damaging enough, but allowing your children to post pictures and stuff to Facebook for others to view, that's that's a very hard thing to control. I would struggle with not what I allow my kids to watch or view or read, but what I allow them to post.
Yeah, that's a good point. I mean, I think you're totally right on the nanny software. I have a coworker who's in sort of this arms race with his kids where, he blocks YouTube, and then they had some other website which is basically a mirror of YouTube, and they just use that to get around it, and then he blocks that, and they have this whole back and forth, and it really doesn't get the message across, which is that ultimately what you want is for your kids to be responsible, and setting up a block and getting your kids to like spend a lot of their time figuring out how to break the system, like, I don't know, might make your kid a great white hat hacker or something like that, but it's not really getting the message. But I think that you're totally right that you should try to, in the beginning, walk your kids through the internet and sort of, hold their hand, as they get through it. And then later on, sort of, I always feel like maybe what I would do is kind of spot check, like if things are going okay, and if there hasn't been anything weird, or if I jump into my kids' emails and there's nothing like weird or anything like that, then you just give them the freedom to do whatever they want. But then if they start getting into things which could be damaging, because ultimately you're responsible. I mean, if they are part of some group that that hacks into, I don't know, some kind of like power plant or something like that, like as a parent, you'll be responsible for that.
And I think it's a judge when you're checking to say, is this something minor or is this something major? Because it's something minor, and it's like the kid who's playing a little rough, and your parents were like fussed when you and your siblings were playing, like, hey, somebody's gonna get hurt. They didn't always stop you. And then somebody would get hurt, and they were right, and you learned your lesson, and that's kind of the way it worked. Versus if you're doing like, juggling torches, they probably would have stopped you, like, hey, don't juggle torches, you're gonna massively burn yourself.
Yeah.
So I mean, I think that's the thing too, is like noticing them doing something that's a little bad versus like something that could cause major harm.
Yep. Yeah, definitely.
So.
It's got to be a case-by-case basis. So I know growing up I was pretty responsible on the internet, like pretty well responsible, but so my parents kind of let me have free reign, even as technology grew and they understood more about the internet. They never really had a problem with that. But then like conversely, it's really bad about doing chores, especially like leaving the laundry. I'd leave the laundry in the washing machine, like just sitting like wet laundry in the washing machine for like a day, and then those clothes are like virtually ruined. Like you have to rewash them. First you have to like let them air dry, then you have to rewash them. And so my parents are always on top of me, like,
all of our listeners are very excited about this. They did not know they were going to tune in and learn about the proper way to fix forgotten laundry in the washer.
And so it's kind of the same way with your kids, right? Like if they, this is just another dimension upon which you have to like sort of monitor your kids' behavior and stuff like that.
I agree. And I think it's, as hard as it is, I guess it's difficult for me. I don't really relate, but people who are parents who aren't, well, I guess they're not listening to our podcast, but parents, for those parents who we all know who aren't as technical savvy, I mean, I think as technical people, you have to help give good advice to those parents,
totally.
Because they really don't know, and there's a lot of people who really don't know anything about computers, and you kind of got to give good advice to those people and help them to know what the right thing.
Yeah, definitely.
All right, well, news.
Yeah.
So it's been a while, but we'll try to keep news to relatively new news. So
that's right.
So there's this thing, you keep seeing it around the internet. At first I thought it was a dessert, Raspberry Pi. And then I realized Pi was spelled like the Greek letter, and it turns out it's a embedded computer device that looks pretty cool. A group of people got together and said, that they want to make a embedded computer that's going to be $35 that runs Linux, and see what people do with it, similar to we talked about on the show before, the Arduino and other such devices. And I heard you had found this already independently, right? You had been looking at these, and you even have your name on the wait list.
Yeah, definitely. I'm on the wait list to grab a Raspberry Pi. It's relatively small. It's embedded. So for people who aren't too familiar with embedded device, basically what that means is it's an entire computer on a single wafer. So on a single sheet.
Board.
Yeah, single board. So I'm trying to pull up the specs on how big it is. I think it's about twice the size of a credit card. So about
right.
2 credit cards you can imagine squarish, stacked square-wise. And so it has many different things on it. So it has, obviously a processor. It has an SD card. So you can pop an SD card, even a 32 gig SD card for storage. There's a $35, which is $10 more than the base $25 model, that has an Ethernet port on it. But other than that, it still has USB, has HDMI out. I think it even has RCA out and stereo out. So you can imagine plugging one of these into your television. You could. It has a GPIO. For people who aren't familiar with that, that's basically a way to...
General purpose input and output?
Yep, that's right. It's basically a way to talk to different things. If you have little motors, so you want to make, say, a robot car or something like that, you could totally use a GPIO interface to talk to those stepper motors or talk to those brushless motors if you're making an airplane or whatever. So you can do all sorts of really fun stuff with it. Do you have any ideas of what you would do if you got one?
These are there's so many cool things, and actually with the baby, you start thinking of you see stuff in the store and I can make something that does the same thing, or feeding the baby takes a long time, so if you give the baby a bottle or whatever and then they drink it, but it takes a long time, they're not good at holding it themselves. I really should design something to hold this so that I can go do other stuff and basically try to be as lazy as possible.
Nice.
But yeah, so constantly I'm thinking of things like that. But I think that having HDMI is really useful. That's something that is traditionally very, and also RCA video, but just having video output built in and so cheap has a lot of things, because we've talked about before, it's very rewarding to program something and see it in video and pictures, and that's why I think part of what game programming is so such a thing that people get introduced to programming through. And this board being so cheap and having that video capability is very intriguing. And what can you display onto a TV? Because everybody has TVs and it's understandable. And your friends, if you show a little motor that spins around, it's like, okay, or look, I blinked this LED in Morse code. Okay, nobody cares. But if you put something up on the TV, and people are like, wow, this is awesome. How did you do this? Yep. So that's really intriguing to me.
Yeah, definitely. I mean, I personally, the first thing I'm going to do on it is get MAME, multiple arcade machine emulator compiled on it. I have no idea why I want to do that. It already runs on my phone.
So can it run Doom?
Everything
else.
else.
It's not a proper computer until it runs Doom?
Yeah, that's right. So get a bunch of those stuff on it. But I think long term, what I'd really want to do with it is either some kind of social communication thing. So maybe a bunch of people at a party or something, you could have this as a centerpiece and talk to it from your phones or something like that.
That'd be cool.
Yeah. And there's definitely, make a robot that can fetch you drinks from the refrigerator or something like that. So
you and thousands of nerds before you have attempted such an endeavor. Will you be the first to completely succeed?
Yeah, it takes power. I don't know if it doesn't have a battery per se, but I'm sure people will add a module for that. It also it doesn't have any type of Wi-Fi like Bluetooth or or wireless, but it does have a USB port, and already some people are mass producing really tiny little Wi-Fi nubs that plug into the USB port and add a little bit to the profile, but
and
gives
Bluetooth
you Wi-Fi.
ones as well, similarly small.
That's right. And I think they're looking at making a new version, like a Model C or something, which will have Wi-Fi. So look out for that in the future.
It could be cool. Something to keep your eye on. And the article that brought this up for the news is not only is this cool, but they've had issues again. We never really talked about it here, but a lot of hardware manufacturers have this. It's very difficult to actually build something, unlike software, which you just kind of release it, and it's still very hard to get rid of all the bugs. But with hardware, not only do you have the issue with the bugs, but sourcing the parts, getting the parts installed correctly, making sure you have the right parts. Somebody could send you a batch. I was reading the other day about somebody who was trying to make a hardware kit, and they got wrong LEDs, and they were counterfeit LEDs, and causes all sorts of implications. So they were going through some troubles with having wrong Ethernet port parts. So
yeah, I saw that they didn't have, proper shielding on the Ethernet, but supposedly it's been fixed now. So, so that's good news. And I honestly think that, save yourself the $10 and buy the one that doesn't have Ethernet and put a Wi-Fi thing on it. I mean, Ethernet
especially if you wait a little bit and see if which Wi-Fi is the best supported one.
Yeah,
and then buy that Wi-Fi.
They're actually, if you go to the FAQ, there's a section on Wi-Fi, and it has a list of like ones they recommend.
Nice.
That's a really important point. So I've done a lot of this kind of stuff before. I've used Gumsticks. Patrick's done a lot with Arduino, and a lot of these embedded operating systems, they don't support a wide range of hardware. So you might go to Best Buy, let's say, and buy USB Wi-Fi, and it just won't work. And it's because so much on the software level just hasn't been implemented for this OS.
Well, and often it's proprietary, so whoever makes that particular stick D-Link or whatever won't release a Linux driver for it, or will release it in such a way that it's very hard to get that to work on other platforms or other devices.
Yeah, so keep in mind that embedded devices run what's called ARM. Most of them run ARM. And long story short is ARM is just a different type of processor than what you have on your desktop. So the instructions are different. For example, like if you want to move data from one register to another, just a way to describe that action in ARM is different. And the set of instructions is different. So because of that, even if you have some USB Wi-Fi adapter that works in Ubuntu, on your desktop, doesn't necessarily mean that it'll work on these embedded systems for that reason. So.
And talk about confusing consumers.
Yeah, so embedded systems require a little bit of thinking beforehand. But the nice thing, the whole goal of this Raspberry Pi is that up until now, even Arduino was close to $100, right?
No, so you can get ones that are fairly cheap. Yeah.
Oh, okay.
The thing is that they're not accomplishing the same kind of task, and they've been around for a lot longer.
Gotcha. Yeah, because I know the Gumsticks, which is similar specs to this, was close to $600. So this being $35, it opens this technology up to a whole new audience, and so I think that people will be much more educated about embedded systems moving forward.
Yeah, and it's definitely a useful skill. Talking about people interested in skills that transfer to the real world. I mean, there are many companies out there doing stuff with embedded computing platforms, systems, and learning how to program in a limited resource environment that these systems represent is a very transferable skill.
Yeah, definitely.
So, talking about making a robot.
Yeah, so we're going to talk now about California being the second state to allow autonomous cars.
So, what was the first one?
So, the first state was Nevada.
Okay.
Yeah, they passed the bill a few months ago. It wasn't that long ago. Up until then, people had been sort of testing autonomous cars in very controlled environments. Then Nevada passed a law not too long ago saying that as long as somebody's in the car, you can have a machine or have a computer driving the car, but there had to be a person there to sort of supervise and take control.
Yeah, so I thought a lot about this. In addition to censorship for kids, no. And so I think about autonomous cars because I really want one. Every day when I commute to work, I think I want that autonomous car. Where is it? When's it coming?
The other week we drove to LA, which is, people don't know, the drive from Northern California to LA is about 6 hours, 7 hours, something like that. So it's a long drive, and the whole time I was thinking, God, if I had an autonomous car, like all four of the seats could just face the middle, and we could be playing Agricola or Power Grid right now. Like
board games.
Yeah, we could totally be board gaming for 7 hours. This is time that is just so valuable.
Lost time.
Yeah.
So I think about this, and it's going to be one of those things that I think is going to, even once the technology enables it, it's still not going to be here. And it's just going to be one of those things that's kind of, because it's going to be so hard. Who do you blame when an accident happens?
Mm-hmm.
The officer shows up, and who does he write the ticket to? What do the insurance companies do? How do they price that in to insure cars that are autonomous? All these situations, or even I know there was one case where an autonomous car was driving and got rear-ended. Well, I don't think the autonomy was on at the time, but even if it did, like, what happens if it's not even the fault of the autonomous car? The first thing that's going to happen is, despite how much to us engineers it doesn't make sense, the first time somebody rear-ends a car that's autonomous, and it was 100% their fault, but they have a really good lawyer, that lawyer is going to bring a lawsuit against the other person saying that they want all the source code for the autonomous car, they want it reviewed, they think it's his fault that it applied the brakes too suddenly, faster than what a human could have, or any of these things, and basically in a fight to try to get overturned, and then it's going to get caught up in a legal quagmire for the foreseeable future.
Yeah, the thing I'm worried about too is, or just interested, I guess more is a better word, is are people going to be able to game the autonomous car? So let's say half the cars on the road are autonomous and you need to get to work. And you're really in a hurry, like you're late for work. If you turn off the autonomous mode, can you like somehow game the AI that's driving the other cars?
So if you flash your lights 3 times and wiggle your car, it thinks you're drunk, and so it gets out of the way.
Yeah, exactly.
And then you can just speed past it.
Yeah. So I think there's almost going to be an arms race between the people who have between the autonomous cars and the human drivers who want to get past them.
Well, I think early the like high occupancy lanes and stuff like this will be enabled for autonomous cars because they can drive so much closer. And so they'll be able to say, like, this is an autonomous car, and they'll have special designated lanes for them or share them so that it's different. Because that is going to be the most difficult time. If we switched completely to an infrastructure that supported autonomous cars and there were only autonomous cars on the road, it would be very simple, actually. Or when you get onto a freeway, it's required that you have autonomy enabled, and you're not allowed to disable it while you're on the freeway. It would be very easy.
Yeah,
but
definitely.
Between now and then, what do you do? Like, you're going to have, in the beginning, very few cars which are autonomous, then slowly more and more and more. And through each of these phases, autonomous cars have to behave differently.
Yep. Yeah, definitely. I think that, in some senses, though, I think that... I just wonder if people will be more or less stressed because they'll be stressed because they could go faster if they were driving it themselves. Part of the whole thing about the autonomous car is that it'll probably do close to the speed limit. I mean, I'm sure the autonomous
but that speed limit in theory will go up because it doesn't even make sense anymore.
Yeah,
because the car will just know what the safest speed it can drive at based on everything.
I wonder if you'll be able to customize it. I wonder if there'll be autonomous car hackers. Yeah.
So I mean, in the state of California, for those of you who don't know, they actually have a thing. So if you want to get your car basically registered to drive, they inspect it and they look for modifications that aren't approved that make it emit too much pollution. They test it to see how much pollution it emits. All these kind of things. There will be a checksum on your autonomous software, and if the checksum for your software doesn't check out, they know you modified it, and they're gonna write you a ticket.
Yep.
Something like that.
So also I recommend you get yourself on the Raspberry Pi waiting list, as I'm on, so that you can write your autonomous car hacker when both of these things are made available.
And if you want to learn how to write an autonomous car, I have another news link for you. Stanford is just starting to roll out some new online courses. So last semester, quarter, I guess last year at some point, Stanford did the first of these, which was machine learning, and I think they had another one as well. And it's by a really reputable, I'm going to mess up the name, Andrew Ng?
Andrew Ng.
Ng, okay.
Yeah, there's a hidden I, not a silent I, but the opposite. There's a hidden I.
So it's Andrew Ng.
Yeah.
And he is a professor at Stanford, and he taught this machine learning class to the internet for free. And it's structured very much like a class that you would take at a college, with exams and everything. But it's all automated and tests and a schedule for you to go through and forums for you to talk on.
And you get a certificate upon completion.
Oh, okay. Yeah. So I started in it, and then I got busy and didn't end up finishing it. And so I actually don't know what happened. But this year, they're rolling out a lot more of those courses. So I'm here on the list, and some of them include the machine learning one again, software as a service. This is a buzzword starting to lose some of its shine, but still important. Natural language processing, so getting computers to work with the spoken and the written word. Cryptography, design and analysis of algorithms. Computer vision. I mean, these are the kinds of things nerds really like. I mean, sorry, we really like. And then they have a few more which are getting ready to come out that are going to be out this year. Probabilistic graphical models. So this is how Xbox's True Skill works on a system similar to this. Game theory, human-computer interaction, computer science 101. Maybe we should have all the parents who allow their kids on the internet to take computer science 101. Maybe that'll. No, okay, that's a bad idea. Information theory and anatomy.
Really? Anatomy?
Anatomy. And I don't think it's anatomy of a computer.
I was going to say, is it like von Neumann anatomy?
No. Computer security and making green buildings.
Really?
So they're starting to branch out, but most of these are still applicable to computer people. And so I would recommend, if you are not a person who's enrolled in college or graduated with a computer science degree or not already a programmer and you want to start learning some of those things and getting involved, this is an excellent, completely free resource for you to use. And I think, so we've had discussions about this at work about having a child, and what is the university system going to be like when our children, become college age? Will colleges as they stand today exist? Will it be completely online? Will it be a hybrid? What'll happen? It's getting so expensive to go to college now.
Yep.
I don't think it's sustainable. That something is going to change. Something will break. And what's it going to be like? And what does that mean for putting away money? So it's so big today because college is so expensive for parents to put away money for their kids to go to college. And if college is going to be completely different in, 18 years, what does that mean? How do you plan for that? What should you teach your children now about learning online so that they can be prepared to be in classrooms where there's no physical teacher?
Yeah, definitely. I mean, I know it took several of my courses on, I think UCF called it Feeds, but I'm sure there's something similar at UF where you take the course online and there's essentially a camera set up in the classroom and things like that, but then you showed up for the exams. So that was starting to approach, totally online. But now I know several courses at many universities are done completely online.
It's a different skill set, though, because there's when you have class, there's some, even if you go, depending on your college and what class and your major and your professor's niceness or not, there's some amount of peer pressure and obligation to show up to class and listen to them talk when they're talking. And that keeps you on schedule. If it's on video, you can always just watch it tomorrow.
Yep.
But if you keep I'm going to watch it tomorrow, you never watch it. And then what happens when you have to show up and take the test? And, there's a level of self-motivation that you have to enforce on yourself there.
Yeah, definitely.
Our online courses at university, I remember, even though they were online and the videos were available, people still would go watch the recording of the video, go watch the teacher be recorded doing it, because that was the only way they could make sure that they would learn the material and do well on the test.
Yeah, definitely. I can say from experience that the machine learning course is awesome. I mean, I took it kind of as a refresher with some of my coworkers, and it was extremely useful. And the cool thing especially about this particular course is that it covers a lot of applied machine learning. So, the guy doesn't go into a whole lot of theory. I mean, there's some of it, what you'd expect from an academic course, but it's a lot of sort of hands-on, very specific examples. And they actually talk about how to do image search, for example, is one of the things they cover in the course. And so they do I think they do Google News. So Andrew Ng actually works for Google. And so he brings up a lot of examples from things that he's done in his career. So if you ever wonder how some of those things work behind the scenes, you can take this course and get it straight from the horse's mouth.
So that almost should have been our tool of the week, sort of. That's an awesome recommendation for people. Very
powerful.
That's
a killer tool. It's almost too good to be a tool.
One day we'll tell our kids, I remember when.
Yeah, back in my day,
the first course came out. And, so that'll be interesting. So speaking of tools, do you have? The tools of the bye week. Yeah, although it's not really been bye week any longer. You can't really say that.
It's a tool of the bye month.
Tool of the semi halfway through the year. So what is your tool recommendation for this recording?
Yeah, so this is a problem that almost everybody has. Is a disk space, right? Whenever I buy a computer, I always buy the lowest processor to let me buy and the lowest memory, and it just doesn't seem to make sense ever to spend twice as much for a better processor when it's going to be out of date. But I always buy the most hard drive space I can, especially with a laptop. But even with desktops, I fill it full of hard disks, and I always invariably seem to run out of space.
So that's interesting, because I actually do the opposite. So I tend to be more willing to spend for a processor or RAM, things which are, in my opinion, more difficult to replace on a laptop or even on a desktop of some sort, and then buy a smallest hard drive, knowing that I'll fill it up and replace it no matter what size I put in. And then as soon as I fill up, I can just go buy it online much cheaper than their upgrade price. I can buy a new hard drive to plug it in and take the old hard drive and make it external.
That works for desktops, right?
No, that works for laptops as well.
Really?
Yeah. Uh-oh.
Wait, how do you swap the hard drive on? Oh, I guess maybe... I don't think you can swap the hard drive on this, can you?
Oh, on a MacBook? I don't know. You have to look online. I'm sure there's a way.
Yeah, there's probably some way.
But most computers, it's fairly straightforward to swap the hard drive.
Yeah.
But continue, sorry. I still fill the hard drives up no matter what. Even more quickly because I buy the cheap one.
Yeah, so basically... these are a set of 3 tools, depending on which OS you use, Windows, Linux, or OS X, which will tell you, in each directory what disks you're using. So, and more specifically, what it does, it gives you these really cool visualizations. So, for example, you could say, oh, your programming directory is like 70% of your hard drive. But then you can drill down and it'll sort everything for you. So you can say like, what in my programming directory is so big? And then you see, oh, my programming/art directory is huge. It has all these art assets. And then drill down there and say, oh, half these art assets are for things I don't use anymore. Let me zip these and put them on a DVD so I don't have to keep them on my hard drive, right? So for Windows, it's called WinDirStat. And if you take a look at that, it's pretty cool. When you run it, it has like these little Pac-Mans. So it starts off with just one Pac-Man, and it has like C:, right? Or maybe it has a Pac-Man for every hard drive. But then it says, oh, C has these 4 directories in it. It has Windows, programming, whatever, users, whatever it has. And it'll create like 4 Pac-Mans that go and scan those directories. Next thing you know, there's like hundreds of these little Pac-Man symbols. It's kind of cool.
Recursively scanning your entire hard drive.
Yeah,
so it does
totally
take a while to run initially, but then after that, the drilling down and exploration goes fairly quickly.
Yeah, that's right. So the idea here is, you kick this thing off, and this is true for all 3 of the programs. You kick it off, you come back like the next day or the morning, and then it gives you all these cool visualizations. Then you go through and start deleting stuff. And it's smart about, if I delete a folder, it goes back and refigures out all the percents and redoes the graph without spending a lot of time there.
So WinDirStat.
Yeah, WinDirStat.
Look on the show notes because it's a little bit complicated to.
Yeah, it's all one word. It's kind of weird, but the show notes has a link. So.
And that's Windows.
Yeah, that's right. On Linux, it's Disk Usage Analyzer. And there's no link for this because it comes built in with Ubuntu. But pretty sure if you run, Slackware or Debian or any of these, distributions, that you'll have some type of Disk Usage Analyzer variant on there. Then for OS X, I use Disk Inventory X. And so this one's a little bit different. It gives you this like sort of like weird quad tree kind of thing where everything's split into cells, but the visualization's not as good as WinDirStat, but it does a similar thing. So
awesome, very useful, very useful. So talking about how effective and productive I am at getting work done, my tool of this week is a game, a free game, not open source but free, Spelunky. And Spelunky is interesting, and I've only played it a little bit, and Jason got so excited when he saw this that this was going to be I think he is more excited about this being a tool of the week than I am.
This game is amazing.
So he's actually played this more. So the idea is you are we're going to get in trouble for saying this, Indiana Jones-like character.
Yep.
So a cave adventurer, Spelunky, referencing spelunking, the act of going down into caves, I assume. Such a clever play on words these nerds are.
Yeah, that's right. Unless you're talking about urban splunking, which is going into like places in Detroit and other like urban abandoned areas.
Okay, I didn't know about this phenomenon.
Yeah,
okay.
That's pretty wild. But yeah, regular splunking is what's going on here in this.
So
game.
your cave explorer explores randomly generated levels. So the game randomly generates you a level, and then you play through it, trying to accomplish the goal of rescuing the princess. I don't know, the girl. And some of them that's the goal. The beginning ones.
I think so.
And the later ones, I maybe it can change. But so even though there's the goal of getting through this randomly generated level, you don't just play on forever. They actually establish a meta game outside of the individual level that you play, and the goal there is that you can continue to accomplish things in each level, and then you can move on through this meta game. And it actually does have a conclusion. Jason informed me of. Spoiler alert.
Yeah, so Splunky's kind of fun. It's a evolution of like NetHack and Rogue and all these games which had and Diablo in a sense, which had randomly generated levels. But the cool thing that Spelunky adds is this mechanic where, it's really hard to go through the whole game without dying because you have one life and you only have, 2 or 3 hits. I think it's 2 hits and then you die. So imagine like Mario, but with one life, right? So it's very hard to make it all the way to like Bowser's castle, right, in one shot. But what the game does to sort of keep you into it is it takes all the points that you've accumulated, in your very short lifespan, and it puts it away. It puts it like in a vault. And these points are accumulated, every time you play. It's just cumulative. So eventually you get enough points where it says, okay, Patrick, you don't have to play level 1 anymore. Like, we're going to start you off at level 2.
Success!
Yeah. So it's like you have like the short-term game of let's see how far I can get. Because if you're super amazing, you could beat the game in one shot. There's nothing stopping you from going right through all 16 levels. But there's also this meta game of, get as many points you can each time you play, and then eventually you'll start off, meeting the boss right away.
So definitely game, check out, free, waste some time. I think it's only supported on Windows. They're working on it, looks like a game for Xbox Live.
Yeah, it looks like someone's made a Mac port.
Oh, okay,
Yeah,
awesome.
I just Googled Spelunky OS X, and there is a Mac port. I don't know if it works or not. Your mileage may vary. But
The disclaimer here, we have no idea.
yeah.
So, and maybe on we could go to the standby of Run It in Wine on Linux.
Yeah, definitely.
So hopefully that'll work for you.
Yeah, Wine's gotten really, really, much better.
But definitely check out spelunkyworld.com, and that'll be in the show notes as well.
Yep.
So I think the time has come, Jason. We are at the discussion of the programming language of the week, Dart.
Yes, Dart. If you Google Dart, you will not find the programming language.
Oh no!
You'll actually have to Google Dart Lang
Okay.
to get even the programming language. It just gives you an idea of how new it is, and also how hard it is to get Google cred for the word Dart. Steal
You think
it
people
away.
wouldn't think of this before they name their languages?
Yeah, like the last Google language was Go, and you'd think
Even
they would
worse.
have learned. Yeah, after Go, you think they would have learned. Let's pick something that's not a common word, but they picked Dart. So
so I guess you let that out of the bag. It's a Google language.
That's right. So it's being worked at by Google engineers, and it has a sort of interesting genesis. So Dart is let's talk a little bit about Dart. It's a client browser based. It's meant to be run in a browser, right?
Okay.
Similar to JavaScript. So basically, Dart tries to kind of get around a lot of the drawbacks, a lot of the weaknesses of JavaScript from an enterprise or a big iron.
Wait,
sort
JavaScript
of
has weakness?
I know, shocking.
Oh, I'm
I think
floored.
we did cover JavaScript. So
yes, so listen to that
definitely-
episode.
Yeah, definitely go back and check that out, and hopefully we'll be consistent. But we're not we're not checking ourselves. So
It's been a while.
It has been a while. People have been born since we did the last show.
Families have increased in size.
It's like Agricola. This is like the next turn.
I actually made that joke. My wife didn't find it funny.
Oh, really?
Yes, you have taken the family growth action.
Nice. But yeah, so one of the biggest things about JavaScript is that you can get errors at runtime. It's not statically typed, and it doesn't have a lot of the things that many other languages like Java and C++, languages which have been used in huge applications. It doesn't have a lot of those features, which make it easy for collaborative development and things like that. So Google actually made a product called Google Web Toolkit, or GWT for short. And Google Web Toolkit, the idea was you would write code in Java, and then this Google Web Toolkit would turn all of your Java code into JavaScript. And this worked out pretty well, but it has some major issues, and we won't really get into that too much detail. But basically, it doesn't really serve the full use case, and it doesn't have a lot of traction. So Dart is an attempt to sort of create a brand new language that can give you kind of the flexibility and the rapid prototyping that you need to make things quick and make web apps quick. Web developers are all about keeping up to date with the latest UI, making something sleek, making it look really nice, making it interact with the HTML, and make it very interactive. And so they don't want to be constrained with all this statically typing. But then on the other hand, you want to write huge programs that run in the browser. And so Dart is a way to sort of balance both of these.
This is an interesting point that when you make a language, everybody thinks they have the right way to make a language, but it's very, very difficult to do everything well.
Yep.
And so oftentimes you make sacrifices by saying, this is what we're going to do well, and if you don't like that, then find another tool, write your own.
Yep.
And so I guess this is Google stepping up to plate and saying there were some things they didn't like about JavaScript, and so they're going to write their own.
Yep. Yeah, and so Google Web Toolkit was just too much of a departure from the things that made JavaScript great. And so Dart is an attempt to sort of bring those closer together. So as we mentioned, it runs in the browser. Right now, there's only a... So let's talk a little bit about virtual machines, right?
Okay, yeah,
so,
we covered that before. But yeah, let's do a refresher.
Yeah. So JavaScript runs on the V8 virtual machine, which runs inside of a browser.
I thought that runs in a car. Oh, sorry, different V8. Oh, see, I knew that.
It runs in an autonomous car.
Ooh.
So Dart can also run in the browser using its own virtual machine called Dartium, I think, or Dart VM, something like that. But now, right now, Dart VM only exists in Chrome, hasn't been ported over.
Which is made by Google.
Right.
Surprise!
Yeah. Ding. So it's not, there's no Dart VM for Firefox or Internet Explorer or any of those. So you might think, oh, if I write my code in Dart, no one else, who uses, no one outside of Chrome can use it. But that's not true. They wrote a compiler called Frog. And so what Frog does is it takes your Dart code and turns it into JavaScript. So you could think of Frog is to Dart what the Google Web Toolkit is to Java. So it's sort of a way to translate your code into JavaScript.
Okay.
But at the same time, if you don't want to use Frog, or or if you're using Dart, you can actually detect the person's browser and say, oh, this guy's running Chrome, we can give him native Dart code. Or this person's running Internet Explorer, we'll use Frog and give them JavaScript.
Yeah. So JavaScript, we talked about this before, has the name Java in it. But the similarities to Java are... So what about Dart? How is it similar to Java then?
Yeah. So Dart and Java are extremely similar. So they're both class-based. They both have classes, interfaces, this whole thing. They have inheritance. And I believe we covered Java, right?
Yeah.
Yeah, we definitely covered Java in a previous episode. So definitely go back to that one. But almost everything in Java... as far as like the architecture, the language, and the semantics, you'll also find in Dart. One nice thing about Dart is that it also sort of gives you some of the features of JavaScript if you want. So, for example, in Dart you can say int x equals 3. And now x has that 3 in it. If you later say x equals Patrick, it'll say an error. It'll say x is an int, and you tried to set it to Patrick. That's not going to fly. And so these are the kind of things that you want as a developer. You want it to give you an error up front. You don't want to have to deploy this code and then your customers run it, and then at runtime they get some weird error because you tried to add Patrick and 10. And at runtime everything blows up after you've deployed it, right? So Dart has that advantage of you can specify the type. You can say, look, this is a number and it'll always be a number. And if it's ever, if ever something comes in that's a string and I set the number to a string, just tell me right away that something bad's happening. Yeah, don't let this compile. So, but it also, you can use var. So if you say var x equals 3, then you're telling Dart, I want x to be anything. So
you can turn it off. You can turn off the static typing.
Yep. And so this lets you be very flexible. So if you really want to hack something up quickly and you want to get out the door, or if you want to be flexible, maybe there really is a variable that could be anything and you want to be able to support that. Maybe some kind of user-generated content or something like that. So Dart will handle that as well.
Very nice.
Yep.
Interesting. Okay.
So another cool feature of Dart that JavaScript does not have is multi-threading. And Dart actually has 2 kinds of multi-threading.
Because one wasn't enough.
Yeah, that's right. If you'll notice, the big thing about Dart, and maybe we'll talk about this later in the strengths, is that Dart seems to try to do everything. It has statically typed, but it can do dynamically typed, and it has many different types of multi-threading. And Dart has all of the Java containers in it, which is something that's really useful. So, yeah, in the case of JavaScript, right, everything is a map. Mm-hmm. So everything is, if you want to say day equals 3, or if you want to do, day equals Monday, if you want to have some kind of enum, everything has to be structured in a map. But in the case of Dart, you can have lists, you can have sets, you can have maps, all the things that you're used to in Java someone's gone in and written and those things in Dart. So it really comes batteries included, as we talked about earlier. So
We like that phrase.
yeah, it's probably my favorite phrase of the show.
Oh, just of the show. Okay.
Yeah, or real life, yeah.
Oh, you use that all the time.
Yeah, pretty much.
Nice.
Yeah, family growth option, batteries included. That's my whole vocabulary.
Wow. Okay. I think we're just going to move on. So you were talking about multi-threading.
Yeah. So Dart has coroutines, and it also has full multi-threading. So have we talked about this before?
We might have at some level, but we can go over it again.
Maybe, how about I'll go over coroutines, you go over like multi-processing.
Okay.
All right. So coroutines are having multiple threads in a single process. So you might say to yourself, like, why would I want to do this, right? And the answer is, let's say you were waiting for someone to type a key on the keyboard, but at the same time you were constantly updating your GUI. Maybe there's some like graphic animation going on in the background, but at the same time you want someone to be able to type in, or you want someone to click a button to stop the animation, right? So you need to be able to do both of these things at the same time. You don't want to have just one loop that says, run a little bit of the animation and then check to see if Patrick pressed the key, and then run a little bit and go back and forth, because this makes the code really confusing. Mm-hmm. What you really want is to have two different things running at the same time. One that's waiting for an input and the other that's running the animation. So you could do this in multiprocessing, where you have two different threads on your operating system that are both doing different things. But this causes a lot of overhead. Anytime you create another process, you have to go to the operating system and say, hey, operating system, I need another space to execute some code. And it has to go and fetch that for you. And that's a little time consuming. Also, as we mentioned, Dart can be compiled to JavaScript, and JavaScript doesn't support multiprocessing. So, there's no way to do that in JavaScript. So Dart has this idea of what Dart calls a light isolate. And this allows you to do coroutines where you have many different threads, but they're all sharing a slice of the same process. So the process will do sort of what I was describing earlier, where it'll play a little bit of animation and then listen for a keystroke. But from a code perspective, you're writing code as if you have two things going at the same time. And the multi-threaded is simulated. So this is different than multiprocessing, which...
Yeah, so multiprocessing, Jason talked about threads sharing a process. And the process is kind of what the operating system deals in. And the operating system schedules processes for the processors to run. And there's overhead there, such as like things that include like the stack. And when you make a thread inside a process, you kind of have to emulate that or eliminate it. And there's all sorts of ways of handling that based on, what you're trying to accomplish. But multiprocessing in theory allows you, if you have a whole process and you have multiple processors, the operating system can schedule one process to run on one and one process to run on the other, and give yourself true multiple things running at the same time versus the CPU just slicing very finely, alternating between two different threads. So as a programmer, if the things you're doing aren't particularly intensive, like, draw some animation, check the keyboard, draw some animation, check the keyboard. If neither of those turn out to be, intensive, or in this case, checking the keyboard most of the time you're just doing nothing, then you can share one process on one processor and it's not a big deal. But if you want to, render the graphics and also compute a path for some entity, if you're doing like, game programming and you want to have AI, those two things are very meaty, intensive things. And if you put them in two threads inside of a single process, it makes it harder for the operating system to know what to do. If you put them in two separate processes, the operating system can say, oh, I'll put one on one processor and one on the other. And then they can run at the same time and in theory make your stuff go twice as fast. There's lots of issues with that simplification, but that's what it means at a low level. But sometimes you don't need that. And there's overhead that's incurred from the processor standpoint, switching the process, having all this extra information that the operating system stores about it, and moving those in and out of the processor depending on what's running is something that you want to avoid if you don't need it. But sometimes you need it, and it's worth it if it means you can get scheduled on two different processors at the same time.
Yeah, totally. So the only other thing I guess I can mention on that is that the heavy isolates, you don't share any data, which, as Patrick mentioned, because they're two different processes.
They can run on two different processes. Yep. Yeah.
So so you have to basically pass messages from one isolate or from the main thread to the isolates. Versus the light isolates, they can actually share data because they know that
they have to be on the same processor.
Yeah, exactly.
So, and then, oh man, we could do a whole episode about that's not language focused, but about the differences and all the different ways that CPUs handle multi-threading and multiprocessing in different languages. And that's something that today is becoming more applicable than ever before, because as processors stop getting faster and start getting more cores, this is something that we have to start worrying about. How do we schedule efficiently 32 cores to do something on the computer? And it's not always straightforward. Most of the time is.
Yeah, definitely. We should do, if we do Go as a language, we should do like a whole thing on
Go tries to address.
Yeah, definitely.
So what are the strengths that Dart? We said it tries to do a lot of things. So what are those strengths it really shines in?
Yeah, so I think one of the biggest strengths of Dart is that it gives you the sort of what's a good way of describing it? It gives you the sort of structure that you're used to as that people have been developing with for years. It's not very often that you see a 200,000 line JavaScript program, and many JavaScript developers will say that's a good thing. It's because we can get it done in 20 lines or something. But the reality is, if you have 30 people working on a project, you really want things to be encapsulated. Maybe that's the best word I'm really looking for. So you want to be able to say, look, this is my graphics handler class for my part of this game. And the way you interact with me is you can say like add sprite, remove sprite. So I'm going to give you an interface with some functions, and you can code to this interface. And then, but internally, I'm going to be doing all the handling of drawing the pixels and things like that. And I'm just going to expose sort of an API. That's the way a lot of these big languages work. Like C++, you have the header file. And you can give somebody the header file without the source file, and they should be able to interact with your code, even though they don't know what's happening under the hood. In the case of Java, they typically use Java docs, right? So you can see a Java doc with the API, and you can code to this API, even if you don't know what the code is doing, because it's very structured. In the case of JavaScript, this doesn't really exist, right? It's JavaScript, everything is an object. And it's very hard, you can define an API, but you're doing a lot of the heavy lifting yourself. Dart sort of takes a step back and says, let's give us more of a Java or C++ feel to browser-based, to client-side browser computing. And that's something that, especially if you go to working with large teams of people, is something that is really beneficial.
It also seems nice that it has the option for the static typing or the dynamic typing. So if you really want dynamic typing and you're in Dart, great, use it. But if you have that static typing to enable those compile time checks and make sure you didn't just try to put a string in an integer or vice versa, or try to add 3 to a string, which doesn't make a lot of sense or is ambiguous, that it's really nice to be able to have that, because it enables, again, if Jason wrote one piece of line of code and I wrote another and I thought he was using a string, in reality he was using an integer, then it could be a problem. And so it's nice to be able to kind of have those enforcements and checks there if you want them.
Yep. Yeah, just to put an example, let's say I was writing this graphics engine and Patrick was using it as part of his game. In the case of JavaScript, I just create a set of functions, but I don't really say, you have to pass in 2 integers and a string or something like that. And in fact, in JavaScript, I believe you can pass the wrong number of arguments and it'll just put in nones, for the other ones. So if I go in and change my API, Patrick might not know. He definitely won't know at compile time because there's no compiler. JavaScript's completely interpreted, right? But even at runtime, it could be just really, the code can just do really strange things that you're not sure of if someone, changes an implementation of something. But with Dart, it sort of allows you to create these modules. And so it allows 2 people to sort of work together in parallel without having to constantly stay in sync.
So we already talked about a little, but some of the weaknesses is that the frog compiler isn't an efficient generator of JavaScript code. You could do better by hand, writing your own JavaScript. Now, it tends to be, with any transition, tends to be the first thing that happens is people go, oh, I could write this better myself. And it's like, well, yeah, but that's not the point.
Yeah, I think at some point someone was telling me, I think when I was in like middle school or something, like, oh, we could do this so much better in assembly, I mean, it's always true, but at the end it comes down to, are you going to pay the price in your, how much time you have to invest or in how fast it's going to run?
So we always try to give some uses of Dart, and I think that's especially difficult because it's pretty early on. I mean, Dart's relatively new. What, a year, less than a year now?
Yeah, I don't even know.
And so, we failed to do a little bit of research, but that's okay. And so it's still pretty experimental, and nobody kind of really knows what Google's intentions are per se with Dart and where they're trying to go with it. And so people are playing around with it. We'll see, what kind of happens, but maybe we do this. This is a little bit earlier in the life cycle of a language than we've done before. But it's something interesting. But Jason, you did find one kind of cool use, one app that was using Dart.
Yeah, it looks like some guys got together and made this thing called Dartendo.
Dartendo.
Yeah, which we'll give a link on the show notes. But it's dartendo.appspot.com, and it looks like it's a complete Nintendo emulator written in Dart. So
wait, so a Nintendo emulator in my browser?
Yeah, it's kind of wild, and these guys drew a little TV graphic around it to make it look like it's make it feel more
retro.
Homely. Yeah, but yeah, it completely runs the NES, and it looks like you can load drag and drop ROMs into it and stuff like that.
So you have to upload your own that you've legally obtained by soldering memory readers onto your Nintendo cartridges and
that's right.
reading the code from. Yes, so, I have many such cartridges that I've done this too.
Yeah, so for everybody out there who has desoldered their Nintendo cartridges that they purchased with their hard-earned money and put the ROMs on their computer, they could do that. Otherwise, it runs a little Nintendo test suite, which that by itself is kind of interesting. You can see how the Nintendo self-tests.
So this has got audio, video, controls.
Yep. Yeah, it seems to have the whole shebang.
Interesting. All right. Well, people can check that out.
It's actually open source, and it looks like it's pretty hefty amount of Dart code. So
okay, so it's always good to be able to look at an application written in a language and kind of get a feel for how people do things or what's being done. So that's definitely useful.
Yeah, for sure.
All right, man. Well, you got anything else? It's been a long time, but it feels good to be back in the not the driver's seat, in the podcasting seat.
Yeah, it does. Yeah, it feels good to be doing this again. We appreciate all the comments. A lot of people were kind of saying, "Hey, when's the next episode?"
We were missed. It's nice to be missed.
Yeah, it's really nice to be missed. Definitely. So it's a lot of fun doing this. We're definitely going to keep it going now that Christmas season has ended and we're both back in our hometown, or not in our hometown, but
back to our place of residence.
Yeah, our landing pad. I don't know what the right word is, but now that we're not traveling all over the place, so it's kind of nice to be back doing this.
Awesome. Well, until next time.
Yeah, have fun hacking with your Raspberry Pi or Arduino or whatever.
If you can manage to buy one.
Yeah. If you can get on the waiting list quick enough.
So, all right. See you next time.
See you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.